December 19th, 2025. 3I/ATLAS passed Earth, and something happened. A golden glow, a spectral shift. Putin joked, "It's our secret weapon. We'll send it to Jupiter." Now, leaked documents reveal Project Orion, a nuclear pulse mission targeting the object at Jupiter on March 16th, 2026. Why intercept a harmless comet billions of miles away with nuclear weapons? What did agencies detect during the flyby that terrified them into this extreme response? Let's dive right in. Let's start with what they told us. Official channels said 3I/ATLAS reached its closest approach to Earth at 270 million kilometers. Safe distance. No threat. Just another space rock continuing its journey out of the solar system. They wanted us to move on, forget about it, go back to our lives. But independent observatories saw something different. At exactly 2:16 a.m. Eastern Time, during the moment of closest approach, the object changed. This wasn't a subtle shift in brightness. This was something that shouldn't happen to a natural comet. Comets are supposed to be dirty snowballs, mixtures of ice, rock, and organic compounds. When they heat up, gases escape and create predictable colors: white from water vapor, blue from ionized gas, sometimes reddish from complex organics. Every comet we've studied follows this pattern. 3I/ATLAS broke the rules. For a brief window during closest approach, it emitted a distinct golden glow. Not the diffuse white of sublimating ice. A metallic golden hue that has no business being on a frozen rock from interstellar space. The data came from observatories in Chile and New Zealand, captured before the files disappeared from public servers. Scientists described it as similar to highly reflective metal or advanced thermal shielding material. Why would a comet have a metallic surface? Researchers tracking 3I/ATLAS noticed something unusual about its tail structure. The object has been showing a secondary tail pointing in the wrong direction. Normal comet tails point away from the sun because of solar wind pressure. It's simple physics. But 3I/ATLAS has an anti-tail that doesn't follow those rules. It's been oscillating with mechanical precision, creating a pattern that radio telescopes picked up as structured emissions. When astronomers analyzed the oscillation frequency, they found timing markers. The signal contains intervals that point to one specific date, March 16th, 2026. The same date 3I/ATLAS reaches Jupiter. The Green Bank telescope data shows the signal changed after the December flyby. Before closest approach, it was a steady pulse, like a beacon. After December 19th, the signal became complex and high bandwidth. Communications experts say it resembles what you'd get when two systems establish a connection and exchange data. It looks like a handshake protocol. A natural comet is sending structured signals that change based on its position and interaction with our planet. How does that happen without intelligence behind it? On December 20th, Vladimir Putin was asked about the comet during a live broadcast. Instead of a routine answer, he said, "It's our secret weapon, but we will only use it in the most extreme case. We'll send it to Jupiter." The media laughed, but two details stand out. He claimed ownership. Our secret weapon. Why would Russia claim ownership of an interstellar visitor? And how did his joke perfectly align with NASA's trajectory calculations, showing 3I/ATLAS will pass Jupiter at 53 million kilometers on March 16th, 2026? That's a specific navigational coordinate, not a random guess. Within 48 hours of Putin's comment, classified briefings were held at the Pentagon, ESA headquarters, and Roscosmos. Travel records show key personnel movements that happen only during crisis assessments. When world leaders suddenly need to discuss a departing comet, something fundamental has changed. On December 21st, articles started appearing about interception strategies for interstellar objects, focusing on Project Lyra and ESA's Comet Interceptor mission. When you understand the physics involved, you realize how extraordinary this is. 3. I/ATLAS is moving at 80 kilometers per second, escape velocity from our solar system. Catching up with something moving that fast requires propulsion technology that doesn't exist in operational spacecraft. Chemical rockets can't do it. Ion drives are too slow. So why are major space agencies suddenly talking about interception? Because they're considering the only option we have. Project Orion, a nuclear pulse propulsion concept from the 1960s. It literally involves detonating nuclear bombs behind a spacecraft to create thrust. It's extreme, dangerous, and violates international treaties. But it's the only propulsion system we currently possess that could reach 3 I/ATLAS before it escapes. Leaked documents suggest a February 2026 launch with Intercept at Jupiter on March 16th. The same date the countdown signal points to. They're planning to meet it there with nuclear weapons. You don't deploy nukes in space for a harmless comet. What did they detect that justified this response? Jupiter isn't just the largest planet. It has a magnetic field 20,000 times stronger than Earth's, extending millions of kilometers into space. Any object passing through Jupiter's magnetosphere will interact with that field in measurable ways. NASA's Juno probe has been orbiting Jupiter since 2016, perfectly positioned to witness whatever happens on March 16th. But NASA has already started managing expectations, warning that Juno's cameras are degrading and may not capture clear images. Here's what they're not saying. Juno has magnetometers, gravity sensors, plasma detectors, and radio instruments that don't depend on optical imaging. Even if cameras fail, those sensors will record any anomalies. The question isn't whether they'll detect something. The question is whether they'll share what they detect. The Golden Glow event on December 19th coincided with a burst of high-energy particles detected by solar monitoring satellites. These particles originated from 3 I/ATLAS. The energy signature doesn't match natural outgassing. It matches a controlled energy release. Then there's the spectral analysis that briefly appeared from a Chilean observatory before being scrubbed. Standard comet composition includes water ice, carbon dioxide, and organic compounds. 3 I/ATLAS showed all of that, but mixed in were long-chain polymers with molecular structures similar to amino acid chains. These are complex organic molecules that typically break down under interstellar radiation during journeys of millions of years. Either this object has some protective mechanism that preserved fragile chemistry across interstellar space, or those molecules were recently synthesized. Both possibilities raise questions a simple space rock explanation can't answer. There's a theory gaining traction among researchers. If you're an interstellar probe passing through a planetary system, you don't stop. Deceleration requires enormous energy. Instead, you deploy a smaller observer package and continue your trajectory. The Golden Glow might have been exactly that, a separation event during closest approach. If something was deployed to monitor Earth, there's one location that makes perfect sense. The L2 Lagrange point sits 1.5 million kilometers from Earth, directly opposite the Sun. It's gravitationally stable, permanently shadowed, and offers an unobstructed view of our planet. We chose it for the James Webb Space Telescope for exactly those reasons. ESA's Comet Interceptor mission is designed to park at L2 and wait for a target comet. But what if they're actually planning to investigate something already there? Something that arrived on December 19th? James Webb has experienced unexplained guidance anomalies since the flyby. NASA attributes them to micrometeorite impacts, but the timing raises questions. Leaked simulation files show something unexpected about how 3I/ATLAS might respond to a nuclear impact. Objects with the thermal and magnetic properties this thing displays don't absorb energy the way normal matter does. The models suggest energy absorption and conversion, like the object could harvest the impact. This creates an impossible choice. A nuclear strike might not destroy it. It might energize it, give it exactly what it needs to activate. So why proceed? Because doing nothing might be worse. Or because they need to force a reaction. If you hit something with enough energy, it has to respond. A natural comet will vaporize. An artificial object will either defend itself or absorb the energy, and that reaction will reveal its true nature. It's a forced disclosure scenario. Right now, 3I/ATLAS is 400 million kilometers from Earth and accelerating faster than solar pressure alone can explain. It's actively maintaining its trajectory, making course corrections that natural objects don't make. When you plot its path beyond Jupiter, it doesn't point to random space. It aims toward the Hyades star cluster, specifically Epsilon Tauri, 147 light-years away. An object that's traveled millions of years seems to know exactly where it's going. The mechanical oscillation continues unchanged. Even as the object moves away from solar influence, the wobble maintains its precise rhythm. It's following an internal program. Between now and March 16th, watch what happens with deep space monitoring networks. Watch for unusual auroral activity. Watch Jupiter observation schedules at major observatories. Whatever happens at Jupiter will answer questions we've been asking since December 19th, or it will raise entirely new ones we're not prepared for. So here's what we know. March 16th, 2026 is 86 days away. That's when 3I/ATLAS reaches Jupiter, when the Intercept mission potentially launches, when we find out if this is an unusual comet or something that fundamentally changes our understanding of what's out there. The evidence is mounting. The golden glow during closest approach, the countdown signal pointing to March 16th, Putin's specific Jupiter reference, the nuclear interception mission that violates international treaties, the L2 package theory. Each piece alone might be explainable. Together they form a pattern that official channels aren't addressing. This isn't speculation anymore. This is documented data from observatories, leaked mission files, and geopolitical responses that don't match a harmless space rock narrative. Something shifted on December 19th, and the countdown to March 16th is already running. I'll be tracking every development, every trajectory update, every signal change between now and Jupiter Intercept Day. If you want real-time coverage as this unfolds, subscribe to Galactic Breaking News and hit that notification bell so you don't miss critical updates. What do you think is really happening at Jupiter? Drop your analysis in the comments. And if this information matters to you, hit the like button so more people see this before March 16th arrives. The universe just got a lot more interesting. Stay informed. Stay critical. See you in the next one.